This is the Team Syntegrity one-day innovation. For many of you, if not all of you, you have an understanding of syntegration. If you haven't done it already, you know what it is about. And so this figure, the icosahedron, colored in the Team Syntegrity colors, this is the Staffordian graph. This is the largest integrity form based on the icosahedron. There are 30 struts, 30 edges, each one with 2 colors. So there are 30 players in this system. And there are 12 nodes. And the cross and interconnectivity of the icosahedron is one of the, well, it is the primary reason why it works the way that it does. Architecturally, this is the same structure as Buckminster Fuller's geodesic dome. And we know that what that means is that you have this, what Bucky called tensile integrity. So you have these orthogonal forces, tension and the compression, that are always at work. And in the icosahedron, it is the only form where those compressions and tensions are completely balanced. So it doesn't matter how large you make the form maintains structural integrity and in fact becomes more efficient, like the hull of a ship. The larger you build an icosahedron dome, the more energy efficient it becomes. So we know that with this integration, we typically have 30 people. Those numbers can shift. You can double some struts. Malik, I think, was working up to 7 people in a meeting. So that would have been 2 times more, quite a few more than the 30 supposed people. And there are 3 iterations of meetings. And since there are 12 topics, 2 meetings take place simultaneously. So one iteration of meetings is all 12 meetings through 6 sessions of double meetings. And this happens 3 times in the staff graphs integration. And what the spectral analysis, as was done by Jalali and reported in From Beyond Dispute, using spectral analysis, is that after the first iteration, about 50% of the information is available. We say distributed, but you're talking about human brains, and not everyone receives information in the same capacity. But the information is, in fact, distributed across the structure. By the time you run the second iteration, you've repeated a sequence after there has been the interactions of all the players moving into different places. Your information distribution goes up to 80%. After the third iteration, you're at over 90%. And if you do more than 3 iterations, you go 4 or 5, you get very small incremental gains. It's an asymptotic curve. So 3 iterations is, for us, gives you the big bang of the 80-20 rule. You get 80% of the bang of a integration out of the last 20% of the time. Remember, you're doing a number of things. You're building a social system, which is typically the largest overhead in a integration, is to get the social system kind of together. The complexity of humans, as we know, is, if not infinite, incredibly large. So the small gains after those iterations. So one of the major problems with this integration is 30 people for 3 to 5 days out of an organization. Now, we've done over 1,000 of these around the world, but they are very, very difficult to sell because of this boundary of entry, which is just expense in pure dollars. These events are usually run in residence. Expense in terms of 30 people from your organization who are doing this, dedicated for 3 to 5 days. We have talked about non-contiguous or online integrations, and we've run a few experiments. But what we're talking about here is the most powerful form, both in terms of its architecture. There is no structure like the icosahedron that would give you that kind of connectivity. And it is the most effective in terms of how it compresses the amount of time. So some people talk about saving months of work and meetings by having gone through a 3 to 5 day integration. So the big question was, for most organizations, is can we do it with less people? can we do it for shorter periods of time? You know, why does it have to be 3 days? So my work initially as the development director was to develop what was called the small forums. And let me show you a quick demonstration of what I mean by that. Let me see if I can get, if I stop my share for a moment. And if I can view speaker. Oh, there you go. Yeah. So this form, this structure I'm holding, this is called a cube octahedron. For you Bucky aficionados, he calls it a vector flexor or vector equilibrium. So what that means is this structure, which is unique in math and geometry and structure anywhere in the universe. There's a sphere that surrounds this. We have the same 12 nodes as an icosahedron. And if I compress this like this, this is the form of an icosahedron. Now, what have I done? I've taken that square face and I've collapsed it until there's an equal edge length that will connect it. And when I do that, this is an icosahedron. So if I take out those 6 opposing struts from 3 orthogonal sets within here, I have a form that has the same 12 connectivity pattern as the icosahedron, but now there are only 24 people. So this was kind of the first way. It is very difficult to deconstruct an icosahedron because of its symmetry, and we wanted to retain the architectonics. We wanted to retain the power that comes from this connectivity, but with less people. So this was the first development, was the cube octahedron for 24 people, but it still took pretty much 3 days. We could cut a few hours off of that. Now, the power of this structure is that whereas the icosahedron is rigid, this structure breathes or oscillates like this, which is very important when you talk about things like cosmology and physics. These things have very specific meanings. But in this case, what happens is I can compress this. There we go. All the way down to a tetrahedron. 4 triangular faces. But this tetrahedron has 4 edges along each length. And what it has done is it has maintained the external connectivity. We haven't disconnected the 12 or have we changed any of the connections among them. I can also compress this into a form called an octahedron, like a pyramid on base to base. And I believe that Elena and Juliana did an event this morning, an exercise.
Yes, we did an octahedron demo.
You did, thank you. Which was 6 topics and 12 players. And this is the form for the octahedron. So obviously this is a smaller one. And what this figure does as well is it retains what's called 2 away from. I have to travel across another node to get to the furthest point. And this is one of the reasons why reverberation works. We'll talk a bit more about that. But this away from relationship. So in an icosahedron, for me to move from one node to another, I have to go 2 across, 2 away from. So I have 2 degrees of freedom in the icosahedron. I have 1 degree of freedom of movement within the octahedron. And when I go down to a tetrahedron, it's a bit floppy. Give me a second here. I go down to a tetrahedron. I do this 1,000 times a day. There we go. This is the smallest form, but this, every node is simply 1 step away from every other node. This is the closest functional connectivity in 3-dimensional space. 4 nodes, 6 connecting sides. And so this would be a very, very small kind of syntegration, but there's no room for reverberation. Everybody is connected to everyone else. And so the information density is very, very high, but that's not very useful for what we want. So what we've done instead is we've created something called a diagonal cube. So you use a cube at 8 sides, or we put into diagonal struts across each of the square faces, and that is a 8-topic 24-person. So the cube octahedron is a 12-topic 24-person. The cube, diagonal cube is 24 people, 8 topics. The octahedron is 12 people, 6 topics. And a tetrahedron would be 4 topics and 6 people, but we don't use that form in that way. So the small forms were the first development, and they started to be used almost from the beginning when many companies kind of were not very happy with the amount of time and effort that it took. So after the development of the small forms, we were looking for ways to, again, reduce the amount of time, but not to lose the connectivity. Reverberation is something that we'll talk about later again, and I'll just give you in terms of reference and analogy of what that means to us. So if you're in a syntegration, you're in a meeting and there's a facilitator and you make a statement, right? This is A. If the facilitator writes it on the board and says this is A, that's not a reverberation. We would call that an echo. The facilitator is trying to feed back the criteria language and the actual words that you use to frame it for you and for others. So that, the same thing, if you said to me, A is A, and I said, yes, A is A, that's essentially an echo. Now, what happens in these meetings is because we have cross-reference participation in different roles in these meetings, I am meeting a bunch of different people in different venues, and this whole thing is kind of cascading around the structure because information is just moving from human nervous system to human nervous system. So if I hear something in one meeting and in another meeting, or even in that meeting, I comment on it. I say, well, I think that this is so, but, and, etc. That becomes what we call a reverberation. It's no longer just a repeat of an echo. It is a transduction through a human nervous system. That is what a reverberation is. And the thing about a reverberation is that, to me, it loosens the language, the specific language that is being used, and allows others to use analogy, metaphor, other ways of relating to that idea. And in that transduction, you're actually reverberating an idea in a different way. So you don't just have the signal, you have the signal, and it's either being amplified or attenuated in some way, but this information begins to reverberate as the meeting iterations take place. Sorry?
Can I ask a quick, would it be okay if we turn this light out? Because it's much easier to see the screen, or I really want the light staying on. Okay, let me try it.
Sorry, let me go back.
It's pretty dark for me.
Okay, so let's go back to here. So this is the next development that we came upon. I don't know what's happening here. Sure, screen.
Yeah, now we can see your slides a lot clearer.
Is everybody okay with the lights off like that?
Yeah.
My screen sharing is paused.
Can you see it?
We can see.
Stop.
I say, down your window.
Oh, here we go. Okay, I'm back.
Yeah, now we can see
I'm not
figure
sure.
2.
I'm sorry?
Now we can see figure 2.
Yeah, thank you. Okay, so these are called the hyperforms. Now, what is a hyperform? If we start with the smallest tetrahedron, this one here, which is a yellow tetrahedron, and on every one of the triangular faces, I build up a starling. So I build another tetrahedron using the same length of edge length. We're working here back to what we call quantum principles. What is the smallest conceivable connectivity? And then how do you build that outwards while maintaining kind of an architectural consistency. And so the tetrahedron is its own dual, which means when you intersect them, they basically create themselves. And so a hypertetrahedron is a tetrahedron with 4 tetrahedra built around each one of those, the inner tetrahedral edges. You can do that with a cube, you can do it with an octahedron, you can do it with an icosahedron. Every one of the regular polyhedra has what is called its dual. So the dual of a tetrahedron is a tetrahedron, the dual of a cube is an octahedron, and the dual of an icosahedron is the dodecahedron. Those are the duals. So what we've done is we're using the duals in this case in order to set up a connection diagram that allows us to maintain a very, very interconnected, joined up kind of group, but at the same time to engineer it in such a way that we can run multiple meetings. Remember, to get any reverberation, we have to do at least 2 reverberations. And if we're looking at a 1 day, it's impossible to do 2 iterations if you have to run 2 meetings at a time. So in this case, what we do is we run 4 meetings at a time. So this is the hypertetra 1-day protocol. This is essentially the model. In this case, we have the colored one. So here's an internal tetrahedron, and on each one of the faces of that tetrahedron, we build another tetrahedron. And we see that these two, a tetrahedron, all the regular polyhedra exist within a sphere where all of their nodes touch the internal surface of the sphere. So we built a large tetrahedron around a small tetrahedron, and so they are embedded. They're in some way recursive. So a 1-day reverberator or syntegration would open typically with an opening question, but because of the shortness of the time, we allow for topics to be pre-established, something that we don't do in syntegration. But in this situation where we have a quite different application, we do allow other ways to work other than an opening question, but this is an example of a kind of an opening question that you might ask. So context for the protocol. As the model shows, there are 2 embedded spheres that are interconnected by the roles each participant would play throughout the day. There's an outer sphere represented by those 4 colors, green, silver, orange, and blue. And then there's the inner sphere represented by 4 other colors, brown, red, yellow, and gold. And this is the connectivity diagram. I have something in my way here. There we go. And what you can see here is that these 4 nodes are the internal tetrahedron. And you can see that they are all connected. They're one away from, but they're all connected to each other directly. The gold is connected to the brown, the yellow, and the red. The brown is connected to the other 3, and so on. So these are all one away from, and they're all connected. But when you look at the 4 nodes of the encircling tetrahedron, the one on the outside, you would notice that they connect to the inside of tetrahedron, but they do not connect across with each other. And what this does is it allows us to run these 4 meetings simultaneously with all the members, because then no one needs to be in 2 places at the same time. So this was one of the tricks to get one iteration where 4 meetings are taking place at the same time, and we can now do 2 iterations in a day. But of course, to do this, you need 4 facilitators, 1 for each room. So the expense dramatically gets reduced to the client in terms of the number of people and the amount of time it takes. These things can be run in-house at a client's place. So let's move on here. Where are we? So in this 1-day event, each person gets to play 4 roles as they move through the meeting sessions. Role number 1 is a member, similar to a syntegration. You're responsible for the final statement or the outcome of the team color. Role 2 is the critic or devil's advocate, again, similar to syntegration. you critique and comment on the content and or process of the meeting. Role 3 is the observer. You attend the meetings, but you cannot speak. And role 4, which is a new role for this, is an advocate or presenter, because someone has to come back to the whole group and present information from the 4 disconnected meetings that took place, where there's no cross connection. So the schedule consists of 3 stages. Configuring the system. Now this is the problems hostile, the marketplace, the voting in terms of what role you're going to play. In fact, what position you're going to play, because you play all the roles in that one position. And we run 2 iterations of 4 simultaneous meetings of the external topic teams, where all participants, all 18 people are engaged. And this is followed by 4 separate meetings, 1 for each of the internal topics. So after the internal members receive the information from the external, they then get together. Pardon me? Yeah. So iteration 2 is a repeat of iteration 1. Each of those takes about 220 minutes. And for closing, we need 20 to 30 minutes. So we're talking about 10 and a half hours if you want to do it all in one day, or you start in the evening if you want to have that social time, and then you run it for 8 to 9 hours on the following day. So where do we go? This is an example of the schedule. I don't intend to go through this in detail, but this is just to show you. You have 4 rooms that are marked based on the color of the topic, and every person, as in this integration, has a defining badge. And this badge is your navigation system. It tells you the colors that you are a member, critic, observer, and advocate of, and it tells you which room you're going to be in which session. And so it's very, very simple in terms of a scheduling algorithm. After that, we have the power storm. Well, sorry, this is the opening of the power storm, generating statements of importance, a problem jostle, and a plenary. And as I said, these events could start with pre-assigned topics, and you'll understand why as we get a bit further on. So the next sequence is the sequence of meetings. So you get the 4 meetings simultaneously taking place, and then you get the 4 separate meetings taking place. And again, what we're talking about is a interconnectivity of the players in such a way that information from the outer sphere gets pushed down into the inner sphere. They don't talk to each other directly. They only get information based on what comes back to them from what has been sent. And again, this reduces some of the time constraints without reducing the variety. Now, when you look at the numbers, 12 people on the outside and 6 people on the inside, you have a 2-to-1 variety reducer from a domain of information. So if you have training as an example, or you have 6 specialists and they want to disseminate information to a group, this could be a very powerful way of getting a lot of information in from expertise into a smaller group, who then have to put that into a plan or a project management or something like that. And this is your final iteration, again, which is repeating. And at the close of the day, you have a plenary session takes place. So as I think it was Vickers who said, the trap is a function of the nature of the trapped. In many ways, we were trapped. We were trapped within an architecture that is the most robust, rigorous, and interconnected one. And the trap is that it takes a lot of people to do it. And from a corporate point of view, from a business point of view, that became a very, very powerful barrier to entry for many, many people who otherwise would have done a integration. So we've kind of reduced the constraints of the trap. Hopefully we will get a few more minds here. So the protocol is designed to maximize everyone's time and to optimize the flow of interactions and information through iteration and reverberation. Now, it engenders direct and indirect cross-pollination of ideas through variety engineered connections, how people connect to each other and in what sequence is a part of that variety engineering. The flow of information is through human nervous systems. Meanings are in people, not in words. What this means to say is that when you're in any kind of information domain, the social overhead, in other words, just people relating to each other, becomes very, very important. And in many group processes takes up a lot of time, actually a lot of non-productive time as you're trying to work out your social exchanges. So in this situation, because the flow of information is happening, you can limit who you're speaking to typically. But what you're dealing with is you're not dealing with words on a page, you're dealing with people who are transducing through living nervous systems. Now, the final point here is that embedment, this recursivity, does not denote hierarchy. It provides the requisite architectonics to manage the variety in and out of each sphere for the different outcomes of the two groups. And the n times n minus 1 equation, there are 18 players times 17 links. There are 306 open loops. So even this very small double tetrahedral is a highly complex in terms of variety structure. Your resource requirements to run one of these is one lead facilitator and 3 other facilitators. You have to have 4 facilitators for the 4 simultaneous meetings. Of course, with AI and whiteboards and AI facilitation, it might be very possible to do all of this on simply mitigated by AI. You need 1 lead host operations and 1 to 2 operations support staff. These are people who are putting messages up on the board and managing the logistics in the background. Your room and space requirements are simpler. You need 1 large room for plenary and posting, which means to hold 18 people or more. And you need 4 small simultaneous meeting rooms that would accommodate up to 8 people, 4 people and critics. And the material requirements are color badges to help you navigate and the individual schedules that allow you to navigate throughout the entire process. So some of the questions that are that need to be addressed in terms of why would you do a one-day syntegration? What is the opening question or the stated purpose of the event? Is there God? Does God exist? Is a very large open question. What do we do in the next week is a very closed question. So you're using a smaller format in order to deal with a complex problem, but you can't deal with every complex problem with a small solution. So the opening question is going to depend on the number of people and what the outcome is that you want. What outcomes are expected and what questions do the teams address specifically? Is there any post-event follow-up required? As we know, coming out of this integration, you have lots of information, but you typically do need a team afterwards to be able to keep it in the organization. So where do hyperset members come from? You look at both the scale and the scope. Is this global, regional, territorial, departmental, or a system within, a subsystem within a system? In the external info set, you need 12 to 18 people to be chosen. And typically this would be because of their expertise. They're bringing information in. The internal info set of 6 to 12 people are what I would describe as the people who will implement the plan or the project management team. So they're taking information from more people than themselves, but they then have to collapse that down into workable goals and plans. Where do the topics come from? Now, this is different to a typical integration because in this case, we can do a problem jostle, a quick one. I think that always helps, but it is not necessary because of this, the 2 connected spheres of information. You can actually predetermine the topics based on how the connectivity is. So this protocol can be adjusted to suit. You have 4 external topics and you have 4 internal topics. And these topics could be subject matter, organizational entities like departments, or goals, or something very, very much more specific. One of the points I'm making in this is that this structure is almost pure architecture. If I think of architecture as structure, form, and function as an example, we provide the structure comes from the polyhedral, from the hypertetra. The form is the choice of colors, the fact that every strut has two colors that allows you to navigate. The function is what the protocol deals with. The function is what is it that you want to get out of this session, and the protocol is designed to do that. So we don't say you have to do this, you have to do that. We give you clean architecture, a structure that has the form that allows you to navigate easily. And the protocol is very easy to adjust to in terms of what it is that you want as a final output. The suggested one-day protocol offers an opportunity to deal with two sets of topics. Here are the inner and outer topics, we call them. And this lends itself to applications where there are two logical sets of topics and one can be embedded in the other, recursivity or subsystem in some way. An example could involve two groups. Let's say one representing system 4, focusing on outside and then, and one representing system 3, focusing on inside and now. They need to meet to agree on a set of plans that are both coordinated and comprehensive. This would apply to all organizational levels, especially where there's a handoff of accountability to an implementation or a project management team. So as shown with the built models above, the tetrahedral basis of the structure, the yellow tetrahedron is the original one, we would call the inner topics, and the 4 tetrahedra on the outside projected will give you the 4 external topics. Now, these are not colored according to the final design. This is just to show you how the structure is formed. The figure on the right shows the network connectivity between those two groups. Again, the 4 inner topics are all connected one to one, and the 4 external topics are not connected across themselves, but are connected by their cross relationships of information that's flowing down and back to them. Yeah. Both the models and the diagram show that there is no direct connection between the 4 outer tetrahedral nodes, which allows these 4 topic meetings to occur simultaneously and provides a source of reverberation. Since the 4 outer nodes are only connected to each other through shared secondary connections of the internal nodes, the 4 internal nodes, being all connected one away from, require 4 separate serial meetings to complete one round. This sequence of meetings, which occurs first with 12 people on the 4 outer nodes, followed by the 4 separate meetings of the inner nodes, constitutes one complete iteration of meetings. Because of the close inter-shared connectivity of the network, only 2 iterations are needed to achieve both reverberation and enough pressure to drive out the requisite level of detail. So protocol development from pure architecture. In terms of protocol development, with the regular hyperduals, which refers to all of the regular polyhedra and their duals, we have clearly delineated embedded levels where, unlike syntegration, where the connectivity is all on the surface, we have 2 interconnected spheres which can be treated as distinct information domains to meet organizational or logical distinctions. The strength is not all on the exoskeleton, as with the icosahedron, where it is required to have away from node relationships in order to create reverberative spaces. We're now dealing with levels of embedment that permit reverberation in the closest direct coupling of any system with a recursive subsystem. What this calls to mind in terms of applications are those that require iterative feedback between 2 levels of logical hierarchy, organization, or categorization, such as we said, system 4-3 interaction or interchange, or for strategic and operational planning and implementation. The structure also would be useful in a learning context where 6 experts are configured with 12 to 24 others to conduct intensive briefings, etc. So this is all about synergistic integrity. How are we doing for time? Buckminster Fuller's tensegrity or tensile integrity is a balance of tension and compression through orthogonal forces in a single structure. It is the basis of synergistic integrity or the syntegrity of team syntegrity forms. The dynamics of the hyperdual forms differ in that tension and compression are dictated by omnidirectional forces that derive both from the structure and its dual form. So you have an exchange of information that's coming off of the surface of one and onto the surface of another. In an icosahedral integration, everything flows on the exoskeleton, on the outside of that structure. So we talked earlier about these concepts of echo reverberation, and I want to introduce the concept of resonance. If I'm speaking to you, as I said, and you repeat the words to me, or I'm a facilitator and I write it on the board, we consider that to be an echo. Now, if I go into another meeting and I hear someone else address this issue, maybe not in the same language, but it's coming from a different place, that person might have been influenced by hearing it from someone who came out of the initial meeting, but the way that they have transduced it in their own nervous system, that is what creates a reverberation. Now, I've wondered all along, what is happening at the 12 nodal points, what we call the topics? You go through one iteration, you get the 12 topics that come out, and that reverberates through the second iteration, and you get some better, finer distinctions within reverberation. And then by the third iteration, those 12 topics have been finalized. The coming about of these 12 resonating topics, this is what we call resonance. And for me, what the Jalali curve and the spectral analysis that Mike Van Winkle has been doing, he uses the term convergence. This is what I mean by resonance. You have within this structure reverberating information that's traveling, is being distributed freely because of the structure. Every nervous system is not going to respond to every reverberation, etc., but the ones that do create amplification. They actually reverberate. A reverberation is different to an echo. A reverberation, an echo is kind of a simple repeat to what's happening. A reverberation is the expansion of something coming out that's a little bit different than what went in. Resonance is the convergence of all of these reverberations across the structure. And so when you look at those 12 topics, you're looking at how the entire system is resonating. That's what we mean by those three terms. I'll take a break here and see if there's any questions that you have. I am within a system. I don't have my headphone. I've had some terrible computer problems before now, so I'm listening to you through speakers. So please speak clearly so I can understand you. And are there any questions? And I'll shut down the share.
Hi, Joe. Can you hear us okay if we speak like this?
Let's view the gallery. Sorry.
Can you hear
sorry,
this?
yes.
Can you hear this, Joe?
Yes, I can hear you, but please, yeah.
Okay. It's Ian Kendrick, Joe. We haven't spoken for a while.
Ian, you might want to go up there.
Yeah. It helps if I can see your face, your lips moving.
Yeah. Can we get the camera to point at us?
Maybe if you went up there, it might work. I don't think so.
The camera's up there. Yeah. Yeah.
You just had
You could wave to him.
You can also switch lights on, please.
Tell me, if I go here,
The camera on the right.
Up there. So if I go here, how's that now, Joe?
It's the same.
Can't see your face.
Yeah.
Oh.
Hell.
Not
That's on the table.
I'm seeing Marcus, and I'm seeing the conference, the front. That's all. Everybody else seems to have switched off their video.
Wave around the waves, you'll see.
Can you see that? No, yes? The little picture, it's this picture here,
Yeah.
I'm talking about, isn't it?
Yeah.
Oh, there we go. Yeah.
There I am. Right. So if I go like that, Joe, can you see me now? Can I be seen there now?
I can see you on the
We can
screen.
see you.
Can you hear me now, Joe?
I can hear you. Chris, you gotta come and help me here.
Okay.
No,
Hi, Joe.
You're,
It's Ian
hi,
Kay.
you're,
Go on. You go, Joe.
yeah, who is speaking?
It's Ian Kendrick. We haven't spoken for a year or so.
Oh, I see. Okay, you're in the front of the stage, in front of the.
I am. Yeah, we're trying to get something that can be seen for you. I've got a really simple
Yeah.
question after all of this.
Is the question not, can you see me, Joe?
Can you hear me? Joe, thanks for the presentation and the slide deck. I'm wondering what you have in terms of a facilitation and design guide for this form of syntegration, because as a one-day exercise, it looks really helpful. That was my question.
You get that?
Asking if there's any material for facilitators.
I can type
Oh,
the question.
Are you asking if there's any material for facilitators?
Yes, to help us actually implement this. Is there an implementation guide that would help us?
Yeah. The facilitation is similar to what we do in this integration.
Yeah,
The facilitator is basically scribing as much as possible, and writing up or helping the team write up the final statement.
yeah. Well, what I'm wondering is it documented so that we can share it with our colleagues to make sure that we are transmitting or indeed transmuting the right messages about how to do this form of integration?
Yes.
Thank you.
Listen, I hate to make it so cumbersome, and I do apologize. We've just moved our house, and in that move, my computer went down. I've had to buy a new one. Haven't been able to get it up yet. So I just had a number of breaks, and then the scheduling thing just kept kicking me out. It wouldn't let me. It let me register, but it wouldn't let me log in. Which is why this morning I had to ask Peter to send me the link. So I'm really fairly badly prepared. I couldn't use my headphones, which is what I would be using. So you're coming through a speaker, which is why it's so difficult.
Right.
So
The question is,
so if you, what can I suggest that if you have a question, you put it into the chat, so I can read the question if not too much.
can you put it in the chat? Okay. The question is, can you share a facilitation guide for this form of integration so that we can show our colleagues how we might.
I don't type so fast.
Okay.
Right. So I have the question about documentation for facilitation would be appreciated
Yeah.
by Ian Kendrick.
Yes.
Yeah.
Yes. Thanks, Joe.
Thanks, Ian. Are there any other questions? Is anyone writing?
Question. I'm not sure how.
Can you go, can you give it to our side?
So my question was, there's a big emphasis in team syntegrity on the lack of hierarchy, but I was curious how it deals with power dynamics as opposed to hierarchy. Say if one of the participants is a CEO and the other is like a low-level employee.
Okay. There's a big question came up. There's a big emphasis on lack of hierarchy, but how power dynamics are still managed. I don't quite understand the question. I think the point about lack of hierarchy really just says that the embedments do not donate one above the other. They could very easily be kind of reversed. So just the fact that you have a small embedment within a larger embedment does not mean that indicates some form of hierarchy or importance. It's all about the variety. You want to get more information into a smaller operating group. And so you expand the information in, but when you come down to implementation or doing the plan, you want the smaller group to be operating. But both of those groups are equally important. That's what I mean. So it's not necessarily, a bunch of executives around a bunch of, factory workers or stuff like that. So the hierarchy that might be implied in these embedments, the same problem we have with recursivity, actually. Hierarchy is a proper word to use, but what is meant here is that hierarchy is not intended. In other words, the structure is not meant to be delineated along organizational lines or importance. It's all about the variety of the discussion. How much information is there? Who needs to take this information and do something with it? That's the small group. The larger group brings the information. The smaller group you could call the decision makers or the plan implementers. How do people come to agreements, decisions? Is it through consensus, voting, or something else? Voting is actually the very last thing that we like to use when it comes down to non-agreement of some kind. And consensus, again, it is an open participative democracy in a sense. And so the rules that apply to that could be the larger group of voters wins the argument. The thing here, though, is to allow people to maintain their integrity of difference. And so what we usually work on in a situation like that is, yes, if it comes down to we cannot make a decision, we can't convince a person to do that, then we work out on the basis of a vote. But typically we would like to stay away from the vote. And I don't like the term consensus in that we don't all have to agree with everything, right? It's how do you find not the lowest common denominator, but what is the highest common factor that we can arrive at? And that usually means that you don't have to have complete consensus. But it is a democratic participative structure. And that's what I mean when I said that this is architecture. The protocol of behavior, I'm not talking about that. People have different values. People have different ways of approaching things. We're not saying here is a protocol you have to use in order to do this. We're saying here is a process template. Here is the structure and the form that will allow you to bring some function to being. How you bring that function to being is a democratic process. So we don't say you have to use, thinking hats, or you have to use this kind of a value equation. Essentially, for me, these structures are value neutral. They are populated by people coming from different circumstances, different backgrounds. That is what we want in the pot, right? The protocol is simply, look, we're going to help you save a huge amount of time. We're going to give you patterns that allow you to share information in a way that we can prove both anecdotally and mathematically is the best way to do this. You cannot, there's no structure other than a tetrahedron in three-dimensional space that does not require 4 nodes and 6 connecting edges. If you take any of those away, you're no longer a three-dimensional structure. We deal within that reality. Dealing in a three-dimensional system allows you to think, I think, three-dimensionally. Yeah. So back to that question, the values introduced into this protocol are brought by the people themselves. Facilitators facilitate conversations by scribing, by feeding back, by helping the teams stay on track. The facilitators do not contribute to content. The facilitators don't tell you what to do. They don't tell you you ought to be using this system. That comes out of the info set, right? And what we believe is that if you give a good pure architecture with an easily navigable set of tools, that what comes out of that is a far richer set of agreements than whether going to consensus or for voting. So I would rather have someone say, you know, I do not agree with this. I want that recorded, right? We go along with it because this is the democratic process. But I retain the right to not have to agree. Excuse me. I'm missing one.
Martin sent you a message.
So let me see what's going on. Right. Okay, so Martin, your question. Martin says, I think this could also be useful for conversations between two levels of recursion. Yes. For example, also discussing what needs to be done by senior management, System 2.5, and what within the autonomy of System 1, or just simply put, decentralization. That's still a core question in organization. I think this is right on, Martin. And I think that these embedments are, in fact, the best way to represent recursivity, right? You're working within a recursive system when you're working in this structure. And I believe that we, at a very deep level, we do get that. It's like when we started to use the icosahedron, there was so much interest in this structure. People were calling me, you're using an icosahedron to do your stuff? My God, I never. So the structure itself has a certain appeal. Today, even more so than 30 years ago. Today, everywhere you look, physics, cosmology, these forms appear in the deepest reaches of math, right? In all different kinds of eigenvalues in different domains. And how is it explained? It really is not. These 5 regular polyhedra are a clue to something in the universe that says these are constraints. And the entire universe are built on these constraints. You don't need any more than these 5 things, right? Now you can change those 5 things up, but I have a form made out of a tetrahedron, an octahedron, and a tetrahedron. And this one form, I can make any object that exists in the universe.
Back here.
Thank you very much for the presentation, Joe. And hello to Chris
Thank
also.
you.
Keep rocking. Very good. Thank you very much for it.